Okay, question 17. Which of the following sketches shows the graph of sine x squared plus y squared equals a half, where x squared plus y squared is less or equal to 8 pi? Okay, so this is a bit of a long question, so I can't show the whole question at once, but I'm going to scroll down a bit so that you could see all the graphs first. So that's A and B, okay, and of course C, D, and E would be right here. I mean, you could I'm sure some of you have the paper printed anyway, so just for those who are just watching. Okay, so how do we know which graph it is? Well, first of all, we've got to figure out what sort of a loci we're working with, right? So if sine of x squared plus y squared is half, that means that x squared plus y squared is how many? It is, well, 30 degrees, right? So pi over 6. What else? 150, so 5 pi over 6. Yeah, and then you just keep on adding 2 pi, right? So it will be 2 pi plus pi over 6, 2 pi plus 5 pi over 6, and so on and so on. Yeah, and up to 8 pi, So how many solutions would you have? How many solutions would you have? You would have 8 solutions, right? Because for every interval of 2 pi, you have 2 solutions. Yeah, for example, from 0 to 2 pi, you have 2 solutions, pi over 6 and 5 pi over 6. Yeah, from the interval 2 pi to 4 pi, you have 2 pi plus pi over 6, and then 2 pi plus 5 pi over 6. Yeah, so every interval has 2 solutions, so in total 8. Good. So what sort of loci are we dealing with? Circles around origin in particular, right? Because x squared plus y squared equals something, equals r squared, we say. Yeah, so we should expect 8 circles first of all. We should expect 8 circles. Yeah, and it seems like every graph has 8 circles. So yeah, if you look here, every graph has 8 circles. Yeah, so it's pretty useless, but sometimes it would be useful. Okay, so what can we do? So if you think about how the solutions are spread out, the pairs of solutions should be closer to each other. What do I mean by the pairs? As in, for example, 30 and 150. Like pi over 6 and 5 pi over 6, they are quite close to each other. Yeah, they are a pair. And then what do we have? We have the next two, they are a pair. Yeah, they are also quite close to each other. Yeah, so we should have these pairs showing up. For example, C is not very good. Let me show you. Why is C not very good? These are evenly distributed. Right? How on earth would they be evenly distributed? That makes no sense. Right? So none of that. And also D as well, right? D is, okay, it gets wider and wider, but there are no obvious pairs going on. Right? There are no obvious pairs of solutions going on. Yeah? So not D either. Yeah? I think A, B, and E, they all have pairs of solutions. Yeah? For example, A, you see 4 pairs of solutions basically. Yeah, because 2 circles are quite close to each other. That forms a pair. Yeah, that means that the original solutions are quite close. That means. Yeah. Okay, then we got to figure out, is it A, B, or E? Okay. So if you talk about the distance between the 2 solutions within each pair is always the same, right? It's always 5 pi over 6 minus pi over 6. That's always the same. So then you would say, okay, it's B then, right? They're evenly distributed. Yeah? But then the issue is these solutions are r squared. Yeah, it's r squared equals all these solutions. So you're going to square root them for the radius. Yeah, you're going to square root them for the radius. And once you square root, the distances change. Yeah. So for example, the difference between square root 2 and square root of 3, is much bigger. It's much bigger than, for example, square root of 34 and 35. Yeah. So the larger you go, once you take a square root, they get very close to each other. Yeah, I mean it's obvious because if you draw the square root graph, it goes like this, right? The gradient gets smaller and smaller. So for the same increase in x, you have less of an increase in y. Yeah, so less difference. Good. So that means that the larger the radii, the smaller my gap should be. Right? So B is wrong because they have even gaps. So A sounds sensible because the largest gap is near the origin, whereas the smallest gap is close to the exterior. So I think it might be A. Let's just check E just in case. E is exactly the opposite, right? E gets wider in the exterior, which is not what we want. Yeah? So that's why final answer is A.